Good afternoon, everybody. Welcome to my session. My name's Andrew Flavel, and today I'm going to be talking to you about how we at Nike secure our AWS infrastructure at scale. First, a little bit about myself. I'm Vice President of Architecture for the Nike Digital team. And what that really means is I work with a group of very talented people building out foundational elements for our cloud platform, our continuous delivery, our service virtualization, that kind of thing. I've been at Nike about 3.5 years, and I really joined Nike to be a part of this digital transformation, taking Nike Digital from a very traditional data center-based approach to services to delivering everything that we do in the cloud. If you're wondering where my strange accent comes from, I'm originally from a small town in the middle of the North Island, New Zealand, so I was wondering if there are any other Kiwis in the audience. Yeah, great. The place where I grew up literally is probably about 10 miles from where they filmed The Shire for Lord of the Rings, so just to give you some idea about that. What I'd really like you to take away from us during this presentation today are 3 things. The first one is how we use a layered approach to security, everything from physical security of our MFA tokens to how we secure our EC2 instances. Next thing is how we use different communications models for different use cases, whether you're a developer trying to SSH into a box or a consumer trying to connect to one of our applications in the cloud. And finally, I want to share with you some really interesting work that one of my teams has done to secure secrets at scale in the cloud. Before we do that, I want to talk a little bit about why Nike cares about digital. You know, at Nike, we're very passionate about sports and the potential for our consumers. And I think it's super telling that when you look at Nike's corporate mission, that innovation and inspiration are really key to what we do. And this, for Nike Digital, this translates into building products and services to serve every athlete personally. So we want to be able to deliver individual recommendations, individualized content to our users at scale, and AWS helps us to do this. And as is usually the case, our digital vision is very complementary to our digital mission, delivering a portfolio of digital products to serve our consumers personally, and Amazon really enables us to do that. When I talk about the portfolio of digital products, there are quite a few, and probably many more than most of you would realize. We have everything from our Nike.com website and our in-store experiences to applications for running with Nike Plus Run Club, training with Nike Plus Training Club, and a number of others. So how many people in this room consider themselves to be sneakerheads? Okay, a few of you. How many of you get up at 5 o'clock on a Saturday morning to get access to our latest product? The Nike people at the front are all putting up their hands. So, you know, one of the applications that we built to really help make access to exclusive product a lot fairer is the Sneakers app. And this is something we built for our sneakerheads to ensure that when they get up at 7 o'clock or 5 o'clock in the morning and they log on, they get the fairest possible approach to getting this exclusive content. So like many of you, we're on a bit of a transformation right now. We're moving out of a traditional IT-centric, big bang application, large deployments, security at the perimeter model, into a much more cloud-based approach. We have cloud infrastructure as a service, continuous delivery, agile practices, microservices, serverless, and it's really exciting for us. When we build out our services, there are a number of key principles that we try to apply everywhere. The first one is that we only give users or other services access to the resources that they really need access to. So that's the principle of least privilege. There's no default trust for any entity within our network, right? So we use a zero trust model to ensure that at each step of the way through the path, through our networks, we're always validating who you are and what you have access to. And if you're doing this at scale, you really need to have automation and self-service nailed. You want to be able to make sure that whenever a developer deploys some code, that code is going to be secure. And you don't want to have overly burdensome manual processes in the way to that deployment. Similar to the principles that I just listed, there are kind of three foundation elements that we use, which I'm sure are very, very common to you all. The first one is authentication. We always check to see who you are. We always authenticate. Authorization. We then check what claims you might have and only allow you access to those parts of the system that you really need access to. This really relates back to the principle of least privilege that I just mentioned. And finally, encryption. We use encryption on the wire and encryption at rest to ensure that our data is as secure as possible. So let's look at our layered security model for a minute. And one thing you could say is, well, what do you mean layers and why do you have layers? And really the real principle behind all of this is that if you have multiple layers of security and you get compromised in one layer, all the other layers are still in place to secure your infrastructure. As I already mentioned, we secure at multiple levels, everything from physical security of our MFA tokens down to multiple layers on the EC2 instances themselves. And I'll talk about each one of these briefly now. We really care about physical security a ton. This is really because if you have your physical security compromised, it means that many of your other layers will become invalid pretty much immediately. So for us, physical security is number one. And I don't know, I assume most of you work for companies, you end up with these access badges. So you want to get access to a building, you need a badge in or badge out. And this is really relevant to us here because we use MFA tokens, hardware MFA tokens for root access to all of our machines. And those tokens are secured in a safe in the Security Operations Center, and the contents of that safe are audited continually. I can guarantee you that being a VP and having this badge does not get me into that building. So that's super important for us. The next layer of our security model relates to IAM and people. So like many of you as well, we have corporate directory service, it could be AD, it could be LDAP, and that's what we use to authenticate who you are within our corporate network. We then use an SSO provider to bridge between our corporate network and our Amazon network. And we map the security groups from our corporate network into IAM roles within our AWS infrastructure. Those roles then have specific authorizations enabled in them. So again, we're taking the authentication that you got from our corporate directory service and mapping it to a set of claims that you're able to make against our infrastructure. From a network perspective, there are a number of things that we do. The only endpoints that should be exposed publicly are those that the public need to get access to. All of the internal endpoints that we have, although they're built as if they would be externally exposed, they're not exposed. So this is really the principle of least privilege. We're only really giving you access to those endpoints that we really want you to see. When we break down our applications, we use a domain model, and typically for each domain, we actually encapsulate a domain within an Amazon VPC. So what this means is that if one of those VPCs gets compromised, it really doesn't affect any of the other VPCs in our ecosystem. In terms of ports and protocols, we're deploying Amazon images all of the time, but most of those microservices don't really need SMTP, they don't need Telnet, they don't need FTP. So these are disabled at the network layer, and they're also not installed as part of our Amazon image. And finally, we use fine-grained controls with network access control lists to really partition out communications at the subnet level. To further support the principle of least privilege, you can control access to AWS services using IAM policies. With them, you control what actions are allowed against those services, which resources allow the actions, and what effect will happen when you access those resources. This is a super simple diagram, and it really just shows that you have a service, service 1, that through an IAM policy is allowed to communicate with an S3 bucket or an SNS topic. Service 2, through an SNS policy, is allowed to connect to the DynamoDB, but it doesn't have the right privileges to talk to the SNS topic, so it's denied. In terms of how we secure our EC2 instances, there are many layers to this as well. The first one really is security groups. We use security groups as a primary method for securing our EC2 instances. And you can imagine that you have a security group for a microservice that allows it to talk to a data store. It could be a Cassandra data store, or it could be MySQL, it could be something else. But the security group really says that service 1 can talk to this data store. No other services can. And so if another service was trying to access that data store, it's denied. We always install a security suite on our EC2 instances. So we have antivirus, intrusion detection, intrusion prevention, and file integrity management. So these are running all of the time on the machines. And as a first line of defense, they're securing our systems and fixing issues that might arise or alerting us if there are issues. This really relates back to a large degree to the principle of automation, right? We don't really want people sitting around watching these machines continually. We have tens of thousands of them, so having the right security suite on the machines is essential to try and reduce the surface attack area. We build immutable AMIs. We really want to know exactly what state every AMI in our system is in, so we don't really allow you to go in after the fact and make changes to configurations in AMIs, to add middleware, to mess around with the different logging and other things. They're baked, they're deployed, and we're done. Obviously, we patch our AMIs in production continuously to, again, reduce the risk from a breach. And we use automation through a central secure configuration service as part of our build pipeline to ensure that, again, all automated, we know exactly what's going into an AMI, we know if it's using a logging system, we know what that is, we know what the configuration parameters are, and this really helps us to diagnose any issues we might have in our systems. Okay, we'll now take a little bit of a look at the communications models that we use in our system. And we use multiple communications models depending on who the actor might be and what resources they're trying to access. There's really no one-size-fits-all approach to this because different users come through different paths. They require different levels of authorization and different types of authentication. So you could be a developer and you're just connecting to an EC2 instance to deploy some code or to debug it. You could be a customer service representative who's a business user and they're connecting to, I don't know, our order capture system to look up an order for a consumer. You could be a consumer that's using one of our applications, whether it's Nike Plus Running or Nike Training Club. It might be that you have a service-to-service call across a VPC boundary for one service to gain access to information that another service might have. Or you could do the same thing, only happens to be within a VPC boundary. And finally, you could be a service or a microservice that wants to talk to its data store, and so they have to have some way of accessing and securing that approach as well. So let's look at the first example where it's either a consumer or an internal business user. These are both very, very similar approaches. The difference really would be in terms of the authentication and authorization. Obviously, the internal business user would use your corporate directory services, whereas a user will use probably authentication through the app layer, probably OAuth, OpenID Connect, and JSON Web Tokens. So imagine they come in through api.nike.com, through our API gateway, through an Amazon ELB, and they hit the service. In this case, it's a RESTful call. We're using TLS for encryption. And as I mentioned, we'd be using auth and authorization and authentication with either the application authorization or our corporate directory services, and we typically use JSON Web Tokens for claims. If we want to communicate from one VPC to another, that happens over the public internet. So again, TLS encryption for this for sure. Again, we're using OAuth and JSON Web Tokens for authentication and authorization. For intra-domain app-to-app traffic, Here we're using security groups. Again, a simple example, it's a private network, there's no publicly exposed endpoints, so Service 1 is able to talk to, I think it's Service 3, I can't see without my glasses. And that's fine, we have the security group set up correctly. Service 3 tries to connect and it's denied. One really key point to make here is that managing the certificates for TLS at scale with tens of thousands of instances is a pretty unwieldy problem from an operational perspective. So in this case, you really do need to make smart choices at what traffic you decide to encrypt as opposed to what traffic you decide to send over the wire in the clear. I think I said this already, RESTful, TLS, and security groups. The next one is you're a developer, you're working at your Mac or your PC, and you want to connect to you want to SSH into an instance to run some tests, deploy some code. One of the common options for this is to use a proxy in NAT or use a Bastion host. In this case, we connect from the corporate network through our proxy to a NAT with an elastic IP and then into our EC2 instance. We use the corporate directory here for authentication, and we use SSH like this specifically because it only allows employees within the firewall to gain access to this proxy. So they're the only people that can even access that proxy, and even when they've done that, they still need the right tokens to connect to the EC2 instance itself. And the last example here is really microservices to Datastore. So it's fairly straightforward. You use encryption via whatever the encryption protocol is that your Datastore might use. You could be using Cassandra, you could be using MySQL, you could be using pretty much anything you like. So at the application layer, we use usernames and passwords. And at the network layer, we use security groups. And so, again, it's encrypted. And we use security groups, and also we use we use security groups, and we use usernames and passwords. And so this is kind of a nice segue into the next part of the talk. So obviously we need to store those usernames and passwords somewhere. And when you have hundreds and hundreds of microservices like we do, and thousands of machines in Amazon, this becomes a big challenge. So what we've come up with is our secrets management and dynamic properties store called Cerberus. Oops, sorry. So who in the audience knows Nike, the Greek goddess of victory? All the Nike people do. So one of the things that the Cloud Platform team has been doing is, as we've been going through building and deploying our services, they like to keep most of their naming around Greek mythical creatures or goddesses or gods. And then Cerberus is a really natural match, right? Because Cerberus is the guardian of the gates of Hades, three-headed dog. And for Nike, for us, it's really the guardian of our secrets. You might ask, well, why did you build this thing? Why didn't you just use something off the shelf? And we actually did look very extensively at what properties were available and whether they would be useful or not. And we really found that although there were some really good technologies available, there wasn't anything that was end-to-end secure. Easy to use and deploy, I think, was one of the biggest challenges we ran into. And really what we'd call kind of cloud native. And so we decided, okay, fine, we'll build something ourselves. And that doesn't mean we build it from the ground up, all of the code. And we took, I think, a very pragmatic approach. So if you look at the APIs that Cerberus encapsulates, there are really kind of three key components on the right. There's HashiCorp Vault, which I'll talk about a little bit more in a minute. There's the management console, which is just a simple microservice that we built. And there's a simple one-page app in S3. If you're a user that's trying to connect to the service, you can either connect to the management console, in which case you'd be using your corporate directory services for authentication and authorization, or you can use a RESTful API. Cloud applications, and pretty much any of our many, many accounts connect via the API, and they use an IAM-based role for that. Oops, sorry. Cool. I'm not sure how many of you are really familiar with Vault, but it's a great tool for managing secrets and very similar to what we're looking for, right? So it secures, stores, tightly controls access to tokens, passwords, certificates, API keys. So we thought out of the box, well, this would be perfect for us. It also provides great tools around leasing, key revocation, key rolling, and auditing. But there are a few things that it didn't provide, and that's why we wrapped another layer around it to help us move forward. It really doesn't provide IAM role authentication, which is really key for us, and we'll actually go into that in a little more detail in a minute. It doesn't also provide user authentication via an SSO provider, which again, for us is pretty much key to how we do a ton of our work. And cloud-native operations and infrastructure were a little bit hit and miss. The biggest thing is it required a non-trivial amount of work to set it up and get it running. And also, it's not really inherently failure indifferent. So really what we did is we built Cerberus, including the management UI for provisioning. We improved the fault tolerance of Vault, and we move forward. What I want to do right now is to walk you through a little bit about how Cerberus works. And we'll do that just through a simple flow diagram here. So the components here we have is an EC2 instance. This is the instance that's trying to authenticate against Cerberus. There's the metadata service that's running on all EC2 instances. This is Amazon's magic URL. And I think I mentioned this earlier, but all Nike EC2 instances get an instance role, right? And this is really useful for controlling what AWS API calls, authentication or authentication is allowed for that instance, and that's stored in that metadata service. Then obviously we have the Cerberus secrets management service itself and Amazon's key management service. So you have the EC2 instance, and it asks the metadata service for its IAM roles, which are then returned. The EC2 instance then asks Cerberus for a Vault token for that particular IAM role and region. Under the covers, Cerberus generates the token using Vault. Cerberus then requests a customer master key from the Amazon key management service for the given role and region. And then requests that Amazon's key management service encrypts the auth token for the given customer master key, and then that's finally passed back to the requesting EC2 instance. Now, once the EC2 instance has that token, it's encrypted. If it wants to do anything with it, it really has to request Amazon's KMS to decrypt the Vault token for the given region and customer master key. Once that's done, the client's free to make requests to the Vault APIs that are composed within Cerberus to read, create, update, and delete secrets. At Nike, we use Cerberus, as I mentioned, to manage passwords, store JOT keys, store certificates, JOT tokens. And the other thing we do use it for is a general purpose runtime config store. And with that, I'd like to invite Nick Martin up to the stage, and he's going to give you a brief demonstration of how Cerberus really works.
Thanks, Andrew.
Number 3.
Okay, that's better. Hey, everyone. So I'm Nick Martin, Director of Cloud Platform Engineering in Nike Digital, working in Andrew's architecture group. And I'm going to take you through a demo today of Cerberus and show off kind of the different components that Andrew mentioned. So what we've got in front of us here is the Cerberus management dashboard. That's that single page app. And it talks to the Cerberus management service and Vault behind the scenes. I'll also be doing some things in the AWS console and basically setting up an end-to-end demo. So in Cerberus, we'll put some secrets in there. We'll secure them, set up access controls in terms of the individuals in our corporate directory services who can access that collection of secrets, as well as set up the IAM roles that are allowed to connect to this set of secrets as well. Then what we'll do is we'll set up a Lambda that is associated with a particular role that's allowed to retrieve that. And finally, connect that to API gateway so that we can actually just with a straight up HTTP GET in the browser actually go and retrieve the secrets that we set up. So let's get started here. So the first thing we're going to do is set up a new application in our dashboards. So we'll call this, imaginatively enough, Cerberus Lambda demo. And it is indeed an application. This right here is just setting ownership of this. And we have a concept that we call a safe deposit box. So a safe deposit box is this collection of metadata. So it ties together a certain named collection with the owner who controls the life cycle of the safe deposit box, along with some permissions. So user groups that are allowed to interact with this safe deposit box, as well as roles. And then finally, we'll set some values and actually put some content in here, some secrets in here. So we'll just say this is reinvent demo, and we will save that off. Looks like I got to log in again. So let's try this one more time. So bear with me. It wouldn't be a great API, it wouldn't be a great demo if a couple of things didn't go wrong. It wouldn't be appropriate. So let's try this one more time. So as you can see, this is using our actual corporate directory service. Okay, so let's do this one more time. So Cerberus Lambda demo. Okay, so this is just saying this group owns it, and hopefully this time, sure enough. Okay, so we've got our Cerberus Lambda demo, safe deposit box, and so far no permissions in here. That's okay, because the next step is we'll actually go over to our AWS console and create a new role that will actually be used for interacting with that. So the role, again, we'll just do this, Lambda demo, so that's our role, and we're going to associate this role with a Lambda. So we'll select that, and we'll attach a policy. So in the sequence that Andrew showed, KMS is a critical portion of this. So the payload that Cerberus hands back is encrypted by KMS. And that is kind of the secret sauce that allows us to do IAM role-based authentication. Because if an attacker were to say, yeah, I've got that role, please give me that bundle of secrets, it'll hand it back, it'll be encrypted. And KMS will not allow someone who does not have the proper role to actually decrypt that collection of secrets. So we've got our role set up, and we'll say create. So it'll work. And let's just take a look at this. Just to show you really quick, the only policy here that we have is one to simply do KMS decrypt. Nothing else in there, nothing else special going on. So at this point, what we're going to do is we're actually, whoops, so we need to go back to roles. What we're going to do is we're going to associate this role with that safe deposit box. So the way we do it is you look at the roles ARN here, and that has embedded in it the account ID as well as the name of the role. And we'll need both of those in our safe deposit box. So what we're going to do is we're going to modify it, and we're going to add new IAM role permissions here at the bottom. So the first thing is that account ID, and the second part is simply the name of the role. So put that in here. And we have the option to either give it read or write permissions. In this case, we only need to give it read. So we'll do that, kind of following our principle of least privilege. And sure enough, we've got now showing up here a role, role permissions here to read. So this is interesting and everything, but it would probably be a lot better if this safe deposit box actually included some content that we want to retrieve. So we'll go ahead and do that. It operates on a path naming scheme, so kind of a hierarchy. In this case, you can see that we already have a path set up that's called app, Cerberus, Lambda, demo. And under here, we'll just give it a new path. Super exciting. And then underneath a particular path, you can have multiple key value pairs. So again, we'll give it this very imaginative name called key. And for value, we'll just say something like, this is my secret, and we will save that. And so at this point, you can see, so we still have our permissions, and now we have a new path under here called path. And by default, it obscures the content because this would typically be some kind of secret. But there's a little reveal icon there so we can see it. So we've got our safe deposit box set up. We've got permissions. And now we've got some content in here. So next thing we're going to do is create the Lambda code that will actually go and retrieve this from Cerberus. So this is just a simple bit of Node.js code, and I'm just going to highlight really quickly what's going on, while in the meantime, we're actually going to package this code up. So we're going to be compressing this and creating a zip so that we can upload it to Amazon, and then the code is simple. You just have a particular region. So this Lambda is going to be in US West 2. We have our account ID, the name of that IAM role that we're going to be using, as well as the host. In this case, we've just got a demo instance set up. The code will go and authenticate to IAM, retrieve the payload, and then decrypt it with KMS. Finally, at the very end here, if everything goes according to plan, it's going to say secret was, and then that value that it retrieves. So we've got our code zipped up, and let's go upload it in Lambda. So we're going to create a new Lambda function. For our purposes, we'll just start with a blank one. We'll just take the default trigger here, and we'll give it the name Cerberus Lambda demo. In this case, rather than editing the code inline, we'll upload that zip that we just packaged up, and we'll go find it. And of course, it's buried deep here. Okay, so we found the zip file, and we're going to upload that. The next thing that we need to do here with our Lambda function is to associate it with a role. So we're going to associate it with that existing role that we created just a couple of minutes ago. And at this point, our Lambda is all configured and ready to go. So we'll say next, and create function. Okay, so congratulations, your Lambda function has been successfully created. Now what we're going to do is we're going to set up an API gateway endpoint so that we can call this just using the browser or curl or any other HTTP tool. So we'll go over to API Gateway, and we'll create a new API. And we're going to call it Cerberus Lambda Demo. Say create. And this is standing up in a brand new endpoint out in AWS. From here, we'll create a resource, and we'll just call this resource demo. So now we've got a path, and we will also create a method so that we can actually call it. And we'll do an HTTP GET. And the integration, so when this HTTP GET is called, we do indeed want it to call a Lambda function. And that Lambda is going to be in US West 2. And there it is. So we'll save that. At this point, it asks us if we'd like to give API Gateway permission to call our Lambda function. And yes, we are OK with that. So that gets saved. And now this is a nice kind of visual representation of what's going on here. So you've got a client, which will be the browser when we do call. It's going to call our API gateway, which in turn calls Lambda, calls our particular Lambda function, and then it just passes the response right back out. So before we're ready to call it from the browser, we need to do what's called staging this, and deploy it rather. So we'll do deploy API, and this will be a new stage, and we'll just go with the default here and call it prod. And if we drill down to our method, this is now our live endpoint, and if I haven't fat fingered anything, see what happens? Oh, that was not good. Let's try this. So it wouldn't be a demo, of course, if something didn't go a little sideways. So let me just go back in here and make sure I got my code all packaged up properly. And we'll try uploading it one more time. Ah. Oh, it was my own fault. I must have, oh, there it is. Yeah, thanks. I did fat finger something. Thank you. Stray key press there. Yeah, thanks to the audience. All right, so now you can tell this is all real. I'm not cheating. So let's go to Lambda, and we'll find our function. And let's upload this again. Okay, I'll save. And I'm not going to test, because that'd be too easy. All right, and just to show you that this isn't all fakery, we can come in here and we can say something like, good catch by the audience on the code typo. Save that. Okay, and let's try it again. And then one final thing before I go is to show the permissions are real as well. We'll go here and revoke that role, save it, and now we better get an error. And sure enough, permission denied. So thanks, everyone. That's it for the demo, and back to Andrew.
Great, thanks so much, Nick. I think that was a great demo, and I hope you guys found it interesting as well. As I mentioned at the beginning of the talk, there were really three things that I wanted you to take away, right? The first one was, it's all about layered security. We use multiple layers from physical to EC2 to reduce risk if a single layer is ever really compromised. We use different communications models which imply different routes, different authentication and different authorization methods depending on who the user is and where they're coming from. And finally, we developed Cerberus to manage secrets such as passwords, API keys, JSON web tokens, and all the other secrets that we want to store at scale in the cloud. Before I close, I just want to step back a little bit and talk a bit more about Nike and innovation. I'm not sure how many of you are familiar with a thing called Nike's Maxims, but you can think of them as the company's core philosophy. It's used to influence, inspire, and challenge employees on a daily basis. And these have been around for a very long time, long before I joined Nike. And I think it's really telling that the #1 maxim has always been, it's in our nature to innovate. And in Nike Digital, we're driving that innovation for our consumers, and AWS is central to our success. Speaking of innovation, we're really excited to announce general availability of Cerberus on GitHub. So we're open sourcing this project. It's available today. You can go to GitHub, download it, check it out. There's also a ton of really, really good, solid documentation on our engineering website, engineering.nike.com/Cerberus. In addition to Cerberus, our engineering teams have been working very hard over the last few years, and we've actually open sourced quite a few other pieces of technology that we've developed. We're not only consumers of open source, we're also very, very passionate about sharing what we've done with you. We have quite a number of projects. This is not all of them. We have a simple Java 8 native client circuit breaker supporting asynchronous futures, blocking, callbacks, and manual mode. We have a distributed tracing solution for Java, a powerful yet lightweight logging library written in Swift, and a JSON parsing framework that leverages Swift to make parsing simple, reliable, and composable. And finally, I really want to give a shout out to some of my colleagues who later on this week, I think it's Thursday, are going to be talking about some of the services that they've developed to really analyze billions of metrics that we capture from our users every day. And so I really encourage you to go to Venetian Level 4, Marcello 440 on Thursday, 5:30 to 6:30 to hear Thomas Lockney and Owen Rakin talk about those. Great, and with that, we're done. So really appreciate your time today. Thank you very much.